pressure, the gases will come out of solution. It's not viable for me to put a heat source on this, it will just melt the plastic and eventually just pop open. The liberated gases will affect design flow. We know that heating and cooling is a design, it's a calculation. Once we affect design flow, the entire system becomes less efficient. We also have issues of noise, so we have a lot of clients or customers saying about noisy systems, noisy pipework, radiators, valves, pumps, and air cupboards, things like that. And we have a reduction or reduced heat output. Radiators that start to form an air pocket at the top will have reduced heat output. This will make the system a lot less efficient. So we need to expel these gases. As the heat exchanger is heating up this water from 30 to 80 degrees, and these are being formed in the heat exchanger on the walls, before the flow carries them into the system, we need to expel these. And that's the job of this item, the deaerator. Okay. So let's see what she does.
Lowering the pressure is equivalent to when you heat water up, gases come out of water when you heat it up.
So decreasing pressure is the same as increasing temperature. There's nothing that's just it. So in this demo rig, I have 1.5 liters of water. You'll be amazed at what can come out in 1.5 liters of water. At home, I have 124 liters. And for the most important component in my system at home, it cost me £1.50. £1.50, that's nothing for the most important component. Now, if I allow that component to become, how do I say, degraded or lose its quality or become extremely costly, and of course the system will become less efficient. So the idea is we run it through the deaerator, and in no time at all, it'll take a bit of time, but the pump goes nice and quiet, and eventually this water will look completely still, as it was before I decreased the pressure. So just to give you an exaggerated point of view, if I turn this up fully, to show you how air affects flow, and you have fast, slow, so you can see this is the restriction that air poses. And a lot of people say, I don't need a deaerator, I have an AAV. Well, this is a very highly engineered AAV, it comes with a 20-year guarantee. But its function is not to remove microbubbles or free air when there's movements of water. It's only when that stops. Then you accumulate a free air bubble, blow it, and then it can remove it. But while there's movements of water, they are near enough redundant. If you run it through the deaerator, in no time at all, you can actually regain the design velocity or flow rate. So they are extremely good at separating dirt particles. And
so that little unit there with the cage in the middle of it, is that unit there?
So this is showing you, this is a visual representation of our technology, which is a spiral tube. It's in all our physical